Hi, welcome to this month's presentation on serverless.NET patterns. Today, we're diving to DynamoDB for fun and glory. If you've played with DynamoDB before, you know that usually the word fun doesn't really apply as much. Until now, I hope. Cool, so here is what I have in store for us today. I assume most of you have worked with DynamoDB or have experimented with it, aware of it. I just want to cover the basics, the types of operations that are possible that I'll be focusing on today with Dynamo. The concept of secondary indices. There's two types. Then I'll talk a little bit of primary and secondary keys and what purpose they serve and how you should think about them. Then we dive into code and actually apply some of these concepts and put them into practice. And we'll have an ally in that particular battle. And then just extra conclusion, what's next kind of topics. Now, usually I just keep it to the agenda, but if you see it says on the agenda, it's because there's also something that's not on the agenda. When it comes to DynamoDB, there just is a whole lot of things that could be covered. And so what I'm not going to be going to depth about, I'll probably be alluding to them and make reference to them. But data access patterns, there's a whole body of knowledge there. I'll give some references at the end where you dig deeper into it. Cost modeling. If you were thinking about doing a PhD, this is DynamoDB cost modeling is probably a good candidate. It's again, I'll give you a reference for where you can actually see what it entails. DynamoDB has this notion of sets that you can do operations on. I'm not gonna dive into those. Quotas and limits, they are really kind of interesting for where they show up, and especially when you work with provision capacity and item collections and things of that sort. And then lastly, hot partitions, which are also a concern, less of these days, but still a concern when you actually do it in the real world. So there's a huge body of additional work. If you want to use it in production or production-like setting and it has real pressure on it, I would highly recommend you familiarize with all the topics on the right-hand side that we're not covering today. They are essential for running it in production, and each one of them is probably deserving of their own session. That said, there's an ally in this battle, not just an ally, basically a champion. Alex Debris, you can find him on Twitter, you can find him on YouTube. He covers a lot of these things, and he's incredibly insightful with his knowledge and generous with his time explaining things. It's a great book. I highly recommend it, called the DynamoDB book. Again, I have a link at the end. Highly recommend it if you do want to use it in production. There just is a lot of depth here. Great. So let's get started. What is DynamoDB? At the high level, and again, this is going to go deep pretty quick because we're going to end up in code. But at the high level, it's a key value document store at the simplest kind of explanation. If you just need to tell someone, hey, what is DynamoDB? It has a couple of things that, though, at least from my experience, set it apart from others, and that is how the primary key, the key that you use to access an item, is created. Now, there's different configurations. However, I highly recommend you go with the composite key always, and you always make the partition key and the sort key components of the primary key strings. There will be a time where that might not be the right advice, and then you will have exceeded my level of knowledge. Right now, for everything I do, everything I've encountered, using this as the standard pattern, and that's what we're going to deploy today, it's a great starting point. And it doesn't make the access patterns anything more complicated. So down here, I have a quick description of kind of, a high representation is a better word for what a table looks like. The primary key is what you need to access an item, and it is composed of these two parts, the partition key and the sort key. You'll see them also referred to as PK and SK. This seems to have been, I don't know who coined or established that terminology, but it works really well. It does have the little caveat that primary key and partition key both abbreviate to PK. So I follow the convention that PK is always the partition key, and I always spell out primary key. So just beware if you use PK for primary key, it might be confusing to someone because it can have two different meanings. Maybe contextually it's clear which one it is, but I prefer to be more verbose when there's a risk of confusion. So you access a row by providing the partition key and the sort key as a pair, and that identifies the row. Now, aside from the primary key, you also have item attributes. This is where you store information about the item in the row. And the sets, the types that are supported are fairly common. As you would expect, string number, binary payload is supported, list, maps, sets, which is kind of special. We're not going to go into depth into it today. And then null can be explicitly represented. So something can be null by virtue of not being there, or null by virtue of being there but having the value null. And so you can associate semantics with that if you'd like so. There is no preset schema, it's schemaless, which means you can mix multiple different types of items inside the same table, which I attempted to represent here. So we have two rows that are customer or some kind of user information, and they have a username attribute and an email attribute. And then there's another row which just has a SKU with some kind of identifier, and they happily live next to each other. As a matter of fact, doing this kind of single table design where you mash multiple things together is one of the key attractive propositions of DynamoDB. And we can leverage some of the abilities of the sort key to actually do some interesting grouping operations that make access to DynamoDB content quite efficient when properly modeled. And again, data modeling is a whole topic in and of itself. Last one I say on here, just a little detail. The reason why partition key is called a partition is, as the name implies, your data is ultimately segmented over partitioned over many different data stores. And within a store, all the items have a total order. So there's always an item that's before and after, and that order is determined by the sort key. So the partition are independent collections, and the sort key is the position of an item inside that collection. That's why you need both. You need to say in which collection is my item in, and then which item is it in that collection. So PK, SK as a pair form a unique identifier for finding or inserting an item. So those are the basic mechanics. So why should you use DynamoDB? Well, that's actually a great question. It's not a straightforward one. And I love it because it's serverless. And specifically, if you have a low utilization volume, it is incredibly cheap. It is $1.25 US East one for 1 million write operations and 1 million read operations. Now, the stat is a little misleading. The write operations are 1 kilobyte in size. So if you write more, then it's a multiple of it. And it's 4 kilobyte on the read side. And then the type of operation read you do, is it a consistent, eventually consistent, or transactional, also has an impact, consulted pricing. However, there's a very generous free tier. It's generous in terms of how much data you can move in and out and how many operations you can do for low usage. You also have conditional operators. So you say that I only want this operation to happen if certain conditions are met. Those are evaluated at the wherever the partition is. I was going to say server, and I just said serverless. So that would be kind of odd. But wherever the partition is, it gets evaluated there, and the operation may or may not proceed based on the condition. So there's many opportunities for not having this race condition where you fetch something, you look at it, and then you put it back. Instead, you can express it in the operation itself. It also has a set of operations they can do atomically in place, such as increment a counter, add an item to a list, check if a list is too long before adding the item. The range queries is what I alluded to earlier, since you know that the sort key provides a total order, you can now do operations on the sort key that gives you a range of items back, which you can leverage for some interesting capabilities or queries. They added transactions a couple of years ago. However, there are transactions around either getting multiple items simultaneously or updating multiple items simultaneously. They're not more the traditional database sense where you open a transaction, you read, you write, you read, you write, and then you close the transaction, and it either commits or it doesn't. These are basically almost like a batch request of update operation, and they either all succeed or none of them succeed. So that's where the transactional semantics apply. And then the secondary indices, which have some interesting properties. We'll go a little bit more detail into there. Now, the drawbacks, though, are significant. They cannot be underemphasized. It gets expensive at scale. Again, if you use the AWS calculator, pricing calculator, it gives you not only an idea of how much it costs you a month, but you should see it gives a very detailed breakdown of how they arrived at how you should basically provision it when you use provision as opposed to on demand. how much you should reserve, how much you should just have over provision, because otherwise requests will fail if you don't have enough capacity. That modeling is shockingly complex. I meant to have a slide here at the end that shows you kind of like the break even of where maybe provision capacity should be thought of, as opposed to on demand. It's not. I was not able to come up with a simple rule of thumb, and because the way it gets measured in one model and the other, the on-demand versus provision, is so significantly different. I'm sure there's a way of normalizing and then they compared. It wasn't trivial enough. It's shockingly hard to use well over the regular DynamoDB client. I've used in the past, and I literally get more confused by expressing my intent in the API than the problem I'm actually trying to solve. However, there we may have a solution now. Operational limits can be they're quite something. Certain things that you expect to work one way may not work the way you anticipated them. There's collection limits, there's read limits of like 4 megabytes for a query, but that's not how much data gets delivered to you. That's how much data gets actually loaded at the partition before it gets sent to you. So you may never see 4 megabytes of data, but you reach the 4 megabyte limit. There are, of course, limits like 400 kilobytes per item that you should be aware of. That's, otherwise it will just reject the write. And so again, the limits and quotas page is one that you're familiar with if you intend to really put, a lot of use, take a lot of advantage of it and really put it to use. So you have to model your data model. That's all recursive. Data access, there we go. Model your data access, because that will determine how your partition key and your sort keys might be structured. So you can do the queries you want to do efficiently. That means also you have encoded a lot of knowledge about those access patterns in your keys. And so it's not as easy just adding a new index as you have in a relational database and you have fast access. You may have to resort to much slower patterns or refactor, and that means you have to convert all the items. So it's not very flexible. It's really best if the model is either relatively simple or is well established, and you just don't anticipate that you're going to have to go through a whole lot of refactoring exercises. Or it's greenfield and it doesn't matter. You just dump the contents of the table. The easiest way to doing that, by the way, is just nuke the table, build a new one. The data will go away automatically. No need to iterate over say the single key and delete it. But once it's there and you have customer data and you need to migrate it, I would anticipate that to be a project in and of itself from everything I've learned to date. And lastly, even though documents stored in DynamoDB look a lot like JSON documents, they are not. They specifically sets are different in the binary, the support for binary data, which means that actually serializing data structures to it and back was a whole different exercise to go through. Again, one hopefully we have now a better solution for. Great. So the most basic operations are get, put, and delete. They're exactly what you expect them to be, your typical CRUD operations. They have a couple of variations. For example, on the get operation, you can tell it that you don't want the entire row back. You only want certain columns. So basically, it fetches a partial result for you as opposed to the entire row. From a billing perspective, you still get billed for the entire row. So if your row was 100 kilobytes, that's what you get billed for, even though you may only return 500 bytes from it, because that operation was done at the partition level before it was sent to you. You'll save on bandwidth and responsiveness in the application potentially, because it's always better to send less data across the wire, but it will not help you on the billing side, so just FYI. Put item has the ability of having a condition. For example, you say, hey, because put both creates and replaces an item, and when I mean replace, I mean it obliterates any attributes that were there before and resets them to the attributes of the new item. So you can set a condition saying like, hey, this item has to exist when I want to put it. I mean, it's an update operation. I don't expect to create anything. Or vice versa, I expect to create something. I don't expect there to be anything. So you can give it a condition of that sort. Or before you update it, that it's in a certain state, like hey, the user is active or the user has been deactivated. Otherwise, don't continue with the put operation. You can also return the values of the row before it was overwritten, in case you need it for backup purposes or any kind of post-processing. And delete item, basically exactly the same notion. You have condition operation, and you can also optionally return the item that was there before it got deleted. All of these operations use the primary key because you're always talking about a specific item in the table, right? You're getting a specific item, You're updating a specific item, you're deleting a specific item. So it's always the primary key used by all of them. The advanced operations were all the fun is though. I mean, this is really where you're just using the basics. You might memcache, Redis, you name it. You have many alternatives. I think this is where the fun begins really, and where the power of Dynamo resides, but was always a little bit out of my range. So the update operation allows you to just send over the data. So you have to send all the attributes. Now you can expect operation like, I just want to update this attribute. It can even be a nested attribute. So if you have stored a map, an object, you can go into it and just update a sub-value of it. Or you can delete that property from a JSON document. Well, I say JSON, but it's a DynamoDB document. You have also some set operation. Again, I don't want to go into those today. They're supported in the library we'll use later. I generally understand the mechanics of it. I haven't applied them to any problem yet that I can speak with authority. That said, they look pretty cool. And then the query operation allows you to fetch multiple rows from a single partition. So you're also going to use the partition key to select the partition you want to query from. But then you can do some very simple and very finite operations on the sort key, range checks basically, to find the sub items in that partition. Results can be mixed. You can provide an additional expression that looks like a condition, similar to what we use for put item, delete item, or the update item operations, but that is used for filtering results. Again, this filtering only happens after the rows have been fetched to the node that handles the partition, and that node has a 4 megabyte limit. So it doesn't, and that's what you get billed for. So it doesn't help you with billing and it or the write capacity and all these things. It helps you though with reducing the amount of data sent back over the wire by specifying what it is that you wanted, or the columns, or the filter itself. So those are the advanced operations. So we'll dive into those today. And then there's a couple of other special operations. Scan is probably the most primitive one of them all. Just return me everything everywhere. There's a filter expression for, again, server-side filtering or partition-side filtering. The other ones are batch, get items, write items, and transact, get items, write items. They're very similar, but not quite identical. Get items is like what you basically, hey, I want to do, I don't remember what the limit is. You have to look at docs. Either 25 or 100 items that you can get. But it's as if you did all these operations simultaneously. So it just goes out and gets all of them for you. If it wasn't able to fetch some because you went to capacity, it gives a corresponding error and a partial result back. Write items allows you to do deletes and puts. That's it. You cannot do updates. Updates are not supported by batch write items, just deletes and puts. That's it. But you can do conditions on them. And then transact, get items is very similar to batch get items, gets you a whole bunch of items. And all of them cannot be in a transitional state due to another transaction. Otherwise, the operation fails and you can reattempt it. Transaction write item, on the other hand, allows you to put, delete, update, as well as just a condition check. So you can say, hey, only if this record has this attribute above that value do I want all the other writes, updates, deletes to actually happen. And again, it does a transaction. All of them happen or none of them happen. That's a really nice, powerful operation. And we'll actually put it to good use today. Great. So let's talk about indices. So primarily, when you get started, you'll have the main table or main index is the only thing you have. You can add other indices to it, which give you new access patterns. Additional cost will be associated when you create them. The local secondary index is very similar to your main index, but it allows you to pick another attribute in your row as being the sort key. So in case you wanted to then do this query operation, you can now do it on a different attribute than maybe you stored it under originally. So it gives you multiple access patterns, but the partition key stays the same for local secondary indices. You can see how the name implies, oh, it's local to the partition. Global secondary indices lift that constraint. You can have any other attribute can become your partition key, and any other attribute can become your sort key. And so, for example, you can swap the sort key and the partition key around. So you have kind of like an inverse lookup mechanism. So it's very, very, very flexible. It needs to have its own capacity provision when it's provision for the main table. Otherwise, it's also on demand. Both local secondary index and global secondary index allow duplicates. So obviously, the main index could not. A single primary key, gee, I get confused here, they represent a single item in the collection. That is not true in the local for secondary indices. The only operation that can access data in the secondary indices are also the query and the scan operation. That's it. You will never make use of the secondary index unless you're using a query or a scan. Most likely query, which is much more efficient than scan, just sends back everything. So I'm trying to remember if we're using a secondary index today or not. One will be deployed, so it's part of the script. And I think it's always a good idea to just deploy it, especially if you have on-demand provisioning, because if you don't use it, it's not really costing you anything. You have to make use of the partition key and the sort key for them to have write traffic. It also seems to have been a convention, again, by reading, everybody seems to have gravitated to it, to just prefix PK and SK by either LSI1 or GSI1 for local secondary index and global secondary index one. You can have multiple of them, and that just makes it easy. Again, what goes into the partition key and the sort key is really dependent on your access patterns and your data models, what you are trying to achieve. It has nothing to do with the records that you actually store, other than that they will supply some values. We'll talk a little bit about that in a moment. Actually, apparently that moment is now. So here was probably one of the biggest key insights I gained while I was working, making my life easier for working with DynamoDB. Again, it's been a live service I've been wanting to use for a long time, and I would lose the forest from the trees. I found it very challenging to be detail-oriented and to use the native API as it is provided by the Amazon SDK. One of the key realizations I came along, and every sample seems to not do this, and that's why I wanted to make it clear here. Your partition key and your sort key are not part of your record definition. Yes, they are being sent over as part of the item so that DynamoDB knows what those values are. But when you take your record definitions, there are no partition keys or sort keys part of it. The partition key and sort key are really a function of the record. So somewhere, which is part of the data access model, you have made a determination that this information, some fields in the record, are being used to generate the partition key and the sort key in order to store it in the table. Similarly, you may have another function which also creates local secondary index 1 sort key value, optional, you don't have to if you don't need it. And the same thing for the global secondary index. These functions have nothing to do with your record directly. They have to do with how you are projecting your records into your table and your indices, which is informed by the access patterns primarily. A model that works for me is you can think of, you want to project a record into a couple of different tables for different purposes. You would have a different projection function that might be computing very different partition and sort keys. But it's the same record. It's the same customer name, this customer email, customer ID, everything in it. The record, what it cares, what it is about, is the same, even though it's stored in multiple different tables. But the way you access those records might be different based on use case. Again, thanks to the flexibility of local secondary indices and global secondary indices, you may actually be able to get over with a single table, which is really cool and efficient because you can then query across multiple items. But do not put your partition, your primary and secondary keys, which is your partition and sort keys, into the record definition. PK, SK, there should be nothing with that name in your record definitions. They look really clean. Instead, you'll have another piece of code that is describing the mapping of the record to the store, the DynamoDB table. And again, we'll put that into practice in just a few minutes. So what I've been busy with the last couple of months, because we wanted to use more DynamoDB in our production environment. And like I said, because the native Amazon DynamoDB client is really tedious to work with, we said, wait, why don't we make our lives easier? We should be able to use link expression. So link expression was introduced in .NET a while ago, whenever link came about. And their capability where instead of a Lambda being passed in as a Lambda delegate, it's actually being passed in as an expression tree. And so the method that gets invoked can analyze the expression tree and retranslate it. It was used for link to data to SQL and operations of that sort. So it turns out that is really nice for what we want to do, because we get the support of the C# compiler. I don't know if it works in F#. I'm not a practitioner of F#. I would imagine it would work, maybe even better, because F# is an incredibly smart language. But the benefit in C# is you get type validation, right? So if you were, for example, trying to set a string to a field that's a number, the compiler will tell you, like, no, you can't do that. Similarly, if you rename a field, a property, it will also, it will, if you use a refactoring tool, it will rename it there as well. You don't have to synchronize these things. I mean, technically, you could do it by hand if you use the name of operator. It's just crazy complicated, and it gets worse. So if we can tap into link expressions and parse them and generate the corresponding DynamoDB conditions or update expression, we can make our lives a lot easier, and we did. and it's gloriously delicious to work with DynamoDB now. I'm gonna be biased in my assessment. The particular library here, LambdaSharp DynamoDB native, it's a standalone library. You don't need anything else. It's designed for single table use. It's not designed for multiple tables. It actually doesn't even have the scan operation, because that one is so trivial to use, wasn't really a headache enough. It's type safe, has a fluid interface. So I don't think what we'll be able to do in the next kind of like 20 minutes, we would be able to do as remotely, as easily, or as confidently if we were just using a DynamoDB client. There's also LambdaSharp DynamoDB serialization assembly. And so you can find this on NuGet. And this one is same thing as system text.json or json.net. It's a serialization library for serializing to DynamoDB attributes. Like I said, the rules of engagement are slightly different. They have a couple of weird little things. So you can't quite go there directly from, you can't go to JSON and then map JSON to DynamoDB. The rules of engagement are a little different. It has support for custom converters. So you need support for new data types or so, and you can just slot them in. Again, pretty much the same experience you would expect from system text.json or json.net, but specialized for DynamoDB. So that might be useful even when you're working with the DynamoDB client and just need to do some document serialization back and forth. Excellent. So I think this is the right time to jump into some code. So the way I organized it, I created a repository. It has two branches. One is kind of like the branch we're going to be working on, the main branch. And then there's another, so-called the solution branch. We like jumping to the end. It's under, and I have the link at the end as well, GitHub/LambdaSharp/serverless patterns-DynamoDB. It should be the most recently published repository. And it just tells you how to get started. So the first thing I need to do is actually deploy the module here. This is a LambdaSharp module. We don't need it for any other reason than this is just creating a data table. LambdaSharp uses YAML syntax that's a dialect of CloudFormation. It's slightly different in how it shows things, but everything afterwards is basically CloudFormation, if you haven't seen it before. And so it creates a table. It is just basically parameterized if you wanted it to be on demand or with provisioned, and then it does the right, it initializes things properly. It creates all the attributes needed for the table itself, as well as the secondary index and the local index and the global index. Key schema, like I said, you should just always use string type until you know why you shouldn't. Unless you have a good reason, always use string. Just you can turn off your brain. PK, SK, string, you're good to go. I also always create an underscore like TTL so that I can have expiring items if I want to. We won't be using them today, and then I define the local index and the second index. You know what? Going through this, I should have started deploying it. Okay, upload, deploy. Okay, that's just uploaded the CloudFormation template and kicked it off. And global secondary index, again, just defined here. I'm also using, so when you create an index, you can tell it if you want just certain attributes to be projected into the secondary index or all of them. It's an optimization to well, you can optimize one way. There's two approaches. Either when you fetch from the secondary index, you ask it to resolve what you fetched against the main table, and then you have more read cost, or you project everything into it, and then you have more storage cost. I am not fluent enough to give one recommendation of the other. For simplicity's sake, I'm projecting all the attributes into the secondary indices. The beep indicates that we deployed it. Took a minute. Okay, and so we have a nice little DynamoDB table here. We should also be able to see it if I pop out of this in my management console. DynamoDB. Assuming I'm in the right region. Yep, here we go. Boom. And of course, it's sparkingly empty. And apparently, I haven't upgraded to the new experience set. Wonderful, because it's actually easier access to items. Oh yeah, great. So we have a table. And we have a table name that got emitted. So we can open the program.cs file, which asks us for a table name at the beginning. Because that's what we're going to interact with. So a try.net and also Jupyter.net workbooks to kind of have something that's interactive and we can work with. I wasn't able to make enough progress with them. So instead, I created a simple program.cs. It's a .NET 5 application. So you see there's no program or main function. It's just all flat code. It's pretty easy to run. And the way I organized it is the first thing it does, whatever table we gave it, it deletes everything to the production table. Don't run this on production anyway. It creates an access client. We have a customer record data structure that we want to store. So I created stubs for basically a lot of the functionality, but it's not implemented yet. That's what we're going to be doing, except for the first one. And so it has a couple of different tasks here we all want to run through. And then at the very end, it has a method for fetching all the items on the tables and just dumping them on the console. Super primitive, good enough for us to learn and try things out. Great. So the initial state of this application, there is, like I said, this is already implemented. I didn't use an interface. This is just straight up a complete class. For production, I would have an IData access interface that the client implements, makes marks and so on much easier. I would also separate between read and write operations. So basically, I have a read-only version of the interface. That makes it easier to know who needs write access. But this is the only operation I implemented. Everything else down here is missing right now, and we will be implementing these. So we're using this, the LambdaSharp DynamoDB.native library. It's called .native to indicate that it's meant to expose the native capabilities of DynamoDB. It's not an ORM. It's really just an easier way to express those native capabilities. So with a fluent interface. So we're calling put item. We're getting the primary key of the customer record. We're giving it the customer record. We're also giving it a condition, which record here is of type customer record. It's just a generic, the type was informed from up here. And then the DynamoDB condition operators, they have like exist, doesn't exist, size, and so on. Those that I couldn't represent easily, they're represented by this Dynamo condition that does not exist. And so we say, okay, we want this condition that effectively the record does not exist. That's my condition. I could also say, I want that the record has, attribute is greater than something. And we use that in a moment. And then I just invoke execute async. So this will just put an item into the table. And since we have code at the end that, oops. Oh yeah, and then when I type run, it's .NET run. I just type it so often that I have an alias for it. We have a couple of variables we didn't use. Okay, great. So let me quickly walk you through this. This is our starting. It shows which table we're using. And then we have only one record, and it got printed out. Actually, since we have the old interface here, that's not too bad. The old one, the new one is really not that nice. Yeah, this is actually pretty good. Hope it's big enough. So these are all the properties that got stored. We can actually open it up on the side and go to the customer record definition itself. It's a simple, plain old POCO kind of style class. I should say that the library is designed targeting .NET Core 3.1 because it's nullable. But it's not yet done for .NET 5 records because Lambdas don't support them. So it's ready for being used in Lambdas that are .NET Core 3.1. Or later if you use a custom runtime. But this is our definition. of the of our object, and you can see how, has a customer ID, has a customer status, that is the enum up here, has a name and email, has a dictionary, which has a key to a customer address field, which is defined down here, and then a number called pending orders. And so if we look into our the item in the DynamoDB table, you can see that address is basically an empty map. There's nothing in it. Here's the customer ID. The email we set, pending orders was not initialized, so 0. Here is the partition key, and then the sort key, and then the status of the customer. Let me go back, because the key here is this get primary key. So get primary key, you may have noticed it's being used as a method on the customer object, but it wasn't here. It's an extension method. Specifically, it's an extension method provided by the data model. So the data model is where you do this mapping from, this is a record, these are the keys I'm using to store the record. The method we're using is this one here, get primary key on customer record. And so it calls another method, which is not an extension method, it's the regular one called get primary key for customer record, which takes a customer, stop the highlights, customer ID, which is the customer ID from the record. There's no validation is in here. Again, this is just illustrative purposes. And then it creates a new primary key with the type customer record as a generic type. And it has these two patterns. And this is basically, these are two format strings. And everything afterwards are the arguments passed into the format string. I found that to be the easiest one to work with, because it allows me then to explain up here as constants what the pattern is. So our primary key for our customer record is the first value we supply, which is the customer ID. And the sort key is simply the value info, because we need for the sort key to be something that's predictable, so we can find, we can set it, and then also later we can retrieve it. All we have is a customer ID. We could just as easily have made this, and actually it's something that Alex Debris does. Ask him why he does it this way versus just make a constant, and he says just that he didn't have an advantage to offer. So it comes down to personal preference. Yeah, great question. So there's a question about why extension method versus directly on the model class. Separation of concerns. By doing an extension, again, can come to personal preference. But if I had it on the class initially, but what I realized was I then bring in all these other concepts that have to do with how did I map this entity into DynamoDB? How did I, what keys that key patterns that define formats for generating the partition key and the sort key. And so I felt by keeping all of that in one place where it's all interrelated was really important. It's not too bad for when you just work with, I think that's another modification. It's not too bad when you just work with primary keys, secondary keys. It gets terrible when you work with queries, because those things, wow, you really wanna, you don't wanna show too much how the sausage is made with queries. We'll look into that in a moment. Because that's where it really got messy, and it uses partial knowledge for potentially multiple different keys. So I felt having a data model class that encapsulates all the complexity of the data model you're trying to capture in your DynamoDB table, for me, it was the right kind of abstraction. Again, your mileage may vary. All right, so we have that. So that part of our code is working. We saw it in action. We see the same output here. It's just printed out as text, but since we have a better visualization in AWS, we might just resort to it. Again, addresses is a map that's empty. These are the attribute value types that DynamoDB uses to identify what is stored in that location. Strings and numbers are stored as strings, which allows, of course, pretty much any kind of number to be stored, which is great, like decimal. You don't have to worry about rounding errors. Cool. All right. So let's tackle our next implementation. Set customer address async. So now we want to set in the addresses property of the customer record, we want to add a field. Again, there's no validation here or anything. So the constraints are set forward as well. I mean, the customer must exist. That kind of makes sense. Remember, update item will create the record if it doesn't find it, unless you tell it not to. And we also want to, we don't want too many addresses to exist. Since we have free-form labels, we just want to limit to 3. And this is actually one where the fun really begins. Great. So we do an async operation. We have our table. Give me completion. Hello. There we go. All right. So we know it's the customer primary key we want to update. And so one of the reasons why the primary key is carrying the type, it's not being used by the class itself, but it informs now where you use the primary key and what type it is. It also, this has been really nice, when I copy pasted code around, it has prevented me a few times from passing the one primary key to the wrong space, because a primary key of customer record is not a primary key of order record. Well, now the types are different. Again, the compiler will tell you, like, wait a second, that's not what you told me it was here. So unintended consequence of the design. Great. So we want a condition. So with condition, this is the callback that represents the record that we're going to be operating under. And so we don't want to have more than 3 addresses. So the condition is Dynamo condition size record.addresses must be less than max customer addresses. It's complaining because this is not yet an operation you can execute or a cancellation token. Yes, thank you. Great. So this now represents that we cannot set more than 3 addresses. It will, at the time it's trying to do the update, it will evaluate this. This is actually being translated into a DynamoDB expression. This is not a Lambda that gets invoked ever in .NET land. Instead, it's being analyzed by with condition and translated. If it can translate it, it will give you an error at runtime at this point. That we want the size to be less than max customer addresses. Well, here's a challenge. If we already set 3 addresses and we just want to update our work address, this will fail because we are at 3. So it's not quite what the constraint said. It said at most 3. So what we want to do is, well, Dynamo condition exists, record.addresses, and then we are storing, what was it called? Sorry, address. That's the subrecord. Addresses. Address. Let me break that over 2 lines just so we can see it a little bit better, and then I'll fix exists. Right. So this checks, well, if work address already exists, you're good to go. Oh, that reminds me, I forgot the first constraint with condition. You can have multiple, they just get ended together. So you don't have to crunch everything into one massive mega statement. Each with condition is an end. Dynamo condition exists. In this case, we just say record. We just want the record to exist, otherwise don't update it. So this is record. This is customer have at most 2 addresses. Okay, so if the address already exists in the collection, we're good to go. Otherwise, we're going to add one. Well, we better make sure that the collection is less than 3. And then we execute it. Probably return that. We have something. Execute returns a Boolean if it was successful or not, since you have a condition. Okay, say run. Yeah, still a variable is not used. I'm going to show it here. Refresh. Right, so now, present as worst nightmare. Exists. Hold on. Either it exists or the usual debugging. Let's take one thing out, see where it failed. And yes, I did practice this before. Oh, okay. Oh, the obvious. Where do I set the address? Great, I have all these conditions. I forgot to set the address. Set. My goodness. Like as my heart comes up into my throat. Okay, record.addresses. The address we want to set. Label. And then comma. So equal is not supported in these predicate, not predicate, the Lambda bodies. So the set operation is basically what you want to set, comma, the value you want to set it. That said, it types checks both. So it's use generic parameters to make sure that this is the customer address, and what you're accessing inside the addresses is also, if the types don't line up, it will not compile. Again, type safety. Now let's try this again. Okay, we have everything, pardon me, run. That would probably help if I actually set it. Ah, there we go. You can already see that it's working. Do I need to refresh this, or will it fetch this one? No, I do need to refresh this guy. Okay. Great. Whew. So the key is work, and then it sets the values accordingly and put it into the map. So now we can, just to make sure that everything is working as expected, we just take this guy, 1, 2, 3, 4, and then we do 4. That was supposed to be 2, but I'm too lazy to go back and fix it, so we'll just go with it. So I'm trying to set 4 addresses. 3 should succeed, number 4 should get us out. Okay, so work 5 is what we don't expect to see. Okay, drum roll. Well, you can already see that's 3 in it. Work 3 and 4 should have been 2. Okay, but as you see, it did not add the other one because it saw that the item didn't exist and the size was already a 3, so just skip. If you ever tried to use DynamoDB expressing that, not easy. The other thing I wanted to point out here is this is a dynamic access to a field in a dictionary. Address.label, the value of it is coming from this execution context, but we are creating a symbolic reference to a key inside DynamoDB. So it's partially in place. So anything that can be evaluated for which we have enough information gets evaluated. So those values get substituted in this expression. And the expression always has to end up in something that is reachable from the record definition. So that's kind of like the mechanics. It's what you would do, but you will get runtime errors if you deviate from it. And so, okay, great. So now we did the first part of our challenge, which is add access to customer record. And we did it so with the constraints, so taking advantage of these capabilities. The next operation is pretty simple. It's just removing something. And so in this case, we say return table. It's also an update item. Again, customer the key. Now I've also remember they have set, add, remove, and delete. Guess which one remove belongs to, which family? It belongs to the set family. It's add and delete work together for set items, which is also confusing. And set and remove operate together. So the remove operation, so first with condition, so I guess it doesn't really matter. That it doesn't exist. I just like to be explicit. Now that it's so easy to do the right thing from the get-go. Oops, cancellation token will be reached. Need to be awaited. Okay, with condition, and then we say what they say remove. No, delete. No, delete is the counterpart to add. Remove is the counterpart to set. Record that. If you look at the input for this, it's the address label we would like to remove. And so that is the addresses. Again, no validation if it's null or anything like that, which would cause all kinds of nice runtime errors. So again, this is a dynamically computed pass. Part of it is evaluated. It will then say remove this item, property from the row. And so what we're doing here, we're running this command. We saw that that was working earlier. We're now running this one. So we expect after this updated application is run, that basically our addresses map is empty again. And it is. So we express that we wanted to remove it. And if it doesn't exist, remove something that doesn't exist, well, I mean, that's an item, that's a no op, right? So we should still have our work address in here and no errors and anything like that. Okay, cool. Now, let's do something more intense. Create order record async. So in this case, we want to store an order for this customer. So we initialize a new order record. It has the customer ID who it belongs to. Here I'm using KSU IDs because they are sorted chronologically, which will be useful as we want to retrieve the 10 recent or X most recent orders with a customer at the same time to be more efficient. We set that the order is pending, and then the program is .NET 5, so I'm using target typing to initialize it. This is a list of order items that then has an order item in it, and I'm just giving some arbitrary values. So this is a decimal value just to show again, numbers are represented as strings, so they have high fidelity in representation. So are the two order items, and then we call the thing our data access client method, which sits on top, which uses the data model to basically do everything. That's why this whole modeling access is so complicated. That's why I wanted to keep it away from the record. So the business logic is a little cleaner. Order record here, this is a decision I made in modeling this particular thing. Remember, a single item in DynamoDB cannot exceed 400 kilobytes. I decided to store all the items that are in an order inside the same row as a nested list. That means, by definition, my customers have an upper limit on how much stuff they can order in a single order. May not be in your best interest on an e-commerce site. That said, it's 400 kilobytes. That's a lot of different items in your order. But it's a design choice, and it may cost me in the future doing it so instead of storing it as a different record, which then comes with its own modeling challenges. This makes it easy. Because when I have an order, I want the items. It also, I can omit the items. When I just want the order and some information about the order, I can say that I just want to get the order ID, the status, and things of that sort, and not the items. And so I save on bandwidth, although I still get billed for it. Cool. All right, so now let's go implement this. Okay, so one is we want to set the order total, because why not? And then allowed most 10 pending orders, and then add the order for the customer. Let's see. Await table. So we want to put an item, and we have the order. So get primary key and the order we want to put. Keep that for a second. So if you look at how the orders are actually stored, here is where I go back to the data modeling that I use. The partition key is the same as for the customer, but the sort key this time has actually information about the order. This means that the order information will be stored in the same partition as where the customer is, and allows me to retrieve the customer and the orders in one quick operation. So that's part of kind of when you start taking advantage of these partition key and sort keys and the properties that they share with each other. I also started off with a pound, and the reason is and you can use any character you like. This one would work too. If you look at the ASCII table, exclamation point is the first character after space. Before that, it's control characters. So it's kind of like the first one in your ASCII values. And since things are sorted by value, it basically means that this info is always coming after, as a sort key, after these guys. Now, I'm not using exclamation point because when I have composite keys that are more complex, I use vertical bar. The vertical bar is the second to last characters, like decimal code 126 or thereabouts, maybe 125. Anyway, you know that one always comes after all ASCII characters, also alphanumeric character. So I'm using pound just because the confusion between apostrophe and vertical bar is just too easy. So pound basically tells me that alphabetically listing, it will be listed first, then anything that is starting with a character. And so that's how it's stored. Otherwise, it's the exact same thing as before. The primary key that is an extension method uses the one that is not. Now, in this case, in order to create a primary key, we need both pieces of information. We need to know which the customer it belongs to and the order ID. Even though the order ID might be globally unique, because it is only a sort key, we need the partition key. However, we could also store now in a global secondary index a reverse lookup if we just wanted to find it by order ID. But we won't do that in this particular example. Okay, so this is actually the part where only allow 10 pending orders for the customer. So we only want to store it if the customer is not like continuously spamming us with orders that are never being paid for, let's say. So I think this is actually where I would like to use a transaction. exact. What are you complaining about? Yeah, no, that is correct. That try execute. Sync cancellation token. Visual Studio, thank you for all your wonderful autocomplete help. Okay, so we're gonna put in here an operation that says begin with item, and it's exactly the same as this fella. And just end. We could put in a condition, of course, that with condition the record Dynamo condition does not exist. Oops, record. So we don't want the record to exist. Then we put it. And the next one we want also begin update item. And this time we want to update the, so we need data model dot get primary key for customer record, and that we need to supply the order customer ID and with condition. Well, for one, we probably want the customer to exist, otherwise that's not great. Dynamo condition. The record. This record has to exist. We also want with condition that record. And my typing precision is dropping quickly because we're almost done, so that's great. Pending orders is less than max pending orders. So only succeed if it exists, and if it's valid, then great. Do a favor and set record pending orders to record pending orders. Again, all of this is being executed by the partition service itself. Don't need this guy anymore. So let me quick orbit. So we're creating a transact write item. We basically want to do two operations. Hey, I want to store the order, but I also want to increase the pending orders counter, but only if it's less than 10. Right? So customer has to exist. We cannot have too many pending orders, otherwise we don't allow any more to work shipped and have been paid for them. But if that's the case, then great. Then increase the pending orders and store the other guy. Either both happen or neither happens. So I got this right. When I hit run, we should now have a new row in our table. Let's see. Yay. All right. And this is the new one. See here, you can see the sort key order. If I click on it, it contains an item with two maps, which are the two nested items. You can also add to this list, by the way, with update operations and so on by using the size operator to basically say, hey, I want to add something at the end of the list, and that will increase the list size. So again, update is just pretty brilliant. And you do it very much the way it was, we did it here, which is by, on the right-hand side, you can refer to the record that is currently stored. This is not being transferred back to you. This is all being executed as part of your query. So it's atomic and in one place. And again, this operation would fail if max pending orders reach 10, because this condition is then false. So this guy doesn't get sick. So wow. As a homework, you should try doing this with the regular DynamoDB client and just see how far you get before you break your keyboard or throw it out the window in frustration. I didn't get very far. All right. Last item, querying. This is by far the most complicated one, because a query is made out of two parts. You have to select a partition key first. So your query can only operate in this one partition key, and then you can ask it to give you back a subset of values in the sort key range. And again, that's limited mostly by size, 4 megabytes, unless you keep like fetching the next payload, Cool. So the way you construct a query, there's a static class called Dynamo Query. And here you express, again, this idea. This is in the data model class, because this is where you define how things are stored, how things are accessed. Again, the idea was to be able to centralize it, so you hopefully keep situational awareness of what you're actually doing. So I'm passing in the customer primary key, but I'm only using the partition key to select the right partition. In our case, we don't store anything else under the, is that correct? This would actually give me back all customer. No, this might be why Alex Debris is doing it the other way. I probably want to say that it starts with order ID. Oh, do I dare changing it on the fly? How confident am I? I think we want the customer ID in here as well. So we want to start with pound. Oops. So in the sort key, we want to repeat the customer ID. And then we want to store the customer ID as here as well. That's probably. Oh no, I can get away with it. Haha. This is where writing things down makes more sense. We know that the orders are always less than the info key. So instead of matching any, which gives us back everything in that primary partition key, that's not great. There's, like I said, there's very few clauses we can do on. Can I please have autocomplete? Dot where? No, wait, where sk less than or equal. So everything is basically written out for us info, which is really what we mean by that is this guy. Since this guy is not playing with me, sk is less than or equals. Okay. Right. So we want the info key, and then we want also things that come before it, right? Because that's why we put the pound character so that it would have the same partition key, but then the sort key and everything before. So now in our data access client, we can use await table query, and now use our data model again, where we say select. So yeah, autocomplete, that's so funny. We pass in the customer primary key, and again, I'm being very verbose for purposes of not confusing PK and primary key. And let's say, oh, and then also the other thing I said here, I'm indicating which types I'm expecting, so that when it deserializes, it can deserialize into the right types up front. And then I say execute async. That returns me a list. I don't think we need to do anything anymore on this. Well, we'll find out. Cool. So the data model has already expressed to us what it is we want to use for fetching a subset of keys. We also told it that we wanted to filter by type. We only want records of this type. And then it also knows what type to deserialize into. We do want a limit that was passed in here. It's not really visible because it's off screen. Limit. Sorry. And then we also have, we need to scan from reverse. Remember, we're matching on info, and then we want the 10 items, 20 items, whatever they are that come before. So, what is it? Scan, index forward. There we go. So there it has it, but then it doesn't auto-complete. Scanning forward, false. So we want to scan in reverse. Great. So this is now a list of objects in terms of type, but typed objects. So what we can do is, if it was successful, and I'm just going to, again, we don't do it here the safest way, customer record. So filter by customer by this type. We expect just only one to be there. And then list of type customer, order record. And that should be good enough for the orders. So what this does, so we, in one single operation, we're fetching the customer record and up to X many records before, or I guess it should be limit plus one if we want up to 10 recent orders, because it includes the customer itself, himself, herself, and then up to that many records before. From that list, we take only what has type customer records. We expect exactly one of them. That's our customer. And then the orders is what comes, basically everything else that's in the list technically, but that's everything of type order record. And that's what we return. So if you look at our program, that's the last operation we do. We do an await, find customer records, async. We store the tuple into found customer. If the customer is not null, we show the customer, and then for the customer, we show all the order records we got back. So we should see one order with 2 items in it. So we hit run. And this is the last of the coding. And then I can do the conclusion. Okay, so let me make it a little smaller. So let's put back up. So here's our customer that we got back. That was the only record of that type. We did single, or would have gotten an exception otherwise. And these are all the orders that were with that customer. So again, one operation, you can do mixed, and then you can use the off-type link operation to parcel out just what you want. So really convenient, fast, development-wise. Not a whole lot of overhead in at runtime either for that particular operation. Great. Okay, wow. So this one did go a little bit long. So let's bring it home. Okay. And then after, I'll open the questions. So what's next? If you look at LambdaSharp samples, they're still using the old DynamoDB client. So basically, the next couple of weeks, all the samples that we have, especially the apps that are more, we'll be upgrading them. So like for example, chats, Lambda robots. Scan operation, like I said, is not supported. It's fairly simple. It has a branch out capability for really fetching a lot of data. It wasn't comfortable enough for me to implement it without fully understanding it, so I left it out. Secondary keys. This is a little bit challenging. Every time you put item or update item, you have to store explicitly yourself the secondary key. There's support for that, but it's done manually. It's just error prone. It's going to cause issues. I have some thoughts on how can make that more reliable, that you basically declare what the projections are, of the secondary keys. So that's just taken care of for you in the update and put operations. Compile time warnings. We want those, while we want the squigglies. We don't want these things to happen at runtime. That's not great. So understanding that you're expressing something that you can't do. You can only do addition and subtraction, for example, or numbers in the set operations, set actions. So if you use multiplication, it will compile, but it will not run. So we can do better by having squigglies at compile time, by doing this analysis that is now implemented at runtime, bring it to the compiler. And then code generation would be next optimization, but I would only work in .NET 5, so I'll leave that as a future exercise. So anyway, if you take one thing away, please don't put your partition keys and sort keys into your record definitions. Always use PK, SK, even if you don't see any need for SK. It's much easier to do at the beginning. You have to tear down your table and recreate it in case you do want it later. Always close PK, SK, always use the string types. Secondary attributes used by second indices are entirely unused, so very error prone. I highly recommend you do some search for data modeling and access patterns in DynamoDB. There's some great videos, in particular by Alex Debris, who also wrote the book, DynamoDB book. Really highly recommend it. If you can expense that work, go for it. He's also active on Twitter. There's also a great DynamoDB Twitter account that actually posts useful information, not just marketing. So it's actually a good source to subscribe to. And with that, you can find the code that we explored today, including the solution at serverless patterns/DynamoDB on our LambdaSharp GitHub repository. And that's it. Hope you enjoyed it. Thanks.